Okay, so as I started working on HackerRank recently, it's been a wonderful opportunity for me to be able to get experience with different types of problems which I have not previously been exposed to. So when you're doing leak code, it's very much targeted towards a specific data structure or a specific algorithm. And now I'm trying to branch out and be able to see problems in a different light, see different types of problems, see how different problems are asked, etc. So trying to get practice with that. And now on HackerRank, what I've noticed is that they have this like problem solving category, which is very much just like a catch all phrase. And I've been trying to, okay, well, if I'm trying to get good at this, first I need to be able to actually classify it and categorize it so that I know how to practice it, how to improve it, what skills I need to actually gain and study. So they have this like problem solving basic. What is that? Like what does it mean? How do I understand this? Obviously, okay, subarray, so I need to know the data structures of arrays. Okay. But then each one seems to be different. And recently I've been trying to wrestle with this a little bit. They also have this thing called implementation. So, implementation, all of these different subdomains here. We have greedy. Okay, that's kind of. We're familiar with greedy and dynamic programming, but a lot of the other ones, like game theory, recursion, we're familiar with from LeetCode as well. Debugging, a lot of these other ones are very different than what we see in the normal like LeetCode map. And so recently I've been just trying to figure out, okay, well, how do I actually go and get better at this? And the strategy which I have been using and I'm going to continue to use is going through these HackerRank problems, and each time I do a problem, okay, great, it gives me an opportunity to be able to look at it, read the question, and actually reading the question in itself is kind of difficult because the way that HackerRank asks questions is very different than the way that LeetCode asks questions. So even reading the question is good practice. But the other thing is, okay, well, now that I'm introduced to different types of problems, I can go and investigate, like, what was my gap in knowledge for this problem, and then try to go and fill that in, and just be able to keep filling in gaps. Now, there's something called, like, simulation, and simulation here on LeetCode is something which seems to be very much I haven't tried it yet. But from when I was talking with like ChatGPT, trying to figure out, okay, well, with HackerRank, what barriers am I coming into? It was suggesting, okay, simulation. So I'm just gonna like see about this topic and get some practice in. Okay, so I don't know what we want to do. Game of life, maybe. Uh, sure. Why not? Why not? We'll see what's going on here. The goal of the video today is just kind of see what this topic is even about, see if it's something which is useful to be studying, see where my gaps in my knowledge are, all of these kinds of little questions. Okay, so let's read this question and see what we get. And then I also am curious, like, how close is simulation LeetCode to HackerRank questions? So we have a fair amount that this is more of an exploratory video. That's what I'm trying to say. It only took me almost 5 minutes. It's an exploratory video. There we go. Alright. According to Wikipedia's article, the game of life, also known simply as life, is a cellular automation devised by the British mathematician John Horton in 1970s. Okay. The board is made up of M by N grid of cells, where each cell has an initial state. Okay, so and I'm continually just making observations as I go. So the first thing that I'm noticing is, okay, we have an M by N grid. Okay, so we have studied grids and matrices, 2D matrix arrays, all of this stuff, right? And so we are going to use that comfortableness that we have with those data structures and be able to implement some kind of puzzle using it, right? That's okay, that's one observation. Where each cell has an initial state, represented by a 1 or dead. Okay, so live is 1, dead is 0. Each cell interacts with its 8 neighbors, horizontal, vertical, diagonal. Okay? Using the following rules, taken from the Wikipedia article above. Okay, so we have a grid, and each cell can interact with its neighbors, and that's directional, right? Like, or spatial, I should say. Here, 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 here. So for any cell with fewer than 2 live neighbors, dies as if caused by underpopulation. Okay, so if you have a cell and it doesn't have more than 2 neighbors, it's going to die. So if it's only 1, kind of like this, it says more than 2 neighbors, right? If a cell has fewer than 2, so no, it is inclusive. So if it only has 1, right, then this cell is going to die. Okay? But if it has 2, right, like this middle cell, it has 1 here, and it has 1 here, okay? It's going to be okay. Any cell with 2 or 3 live neighbors lives on to the next generation, okay? Any cell with more than 3 live neighbors dies as if by overpopulation, okay? Any cell with exactly 3 live neighbors becomes a live cell. Okay, so if you have a dead cell and it has 3 live neighbors, exactly 3 live neighbors, it comes to life. Okay. The next state of the board is determined by applying the above rules simultaneously to every cell in the current state of M by N grid. In this process, births and deaths occur simultaneously. So it's stage by stage, so like second by second. Meaning, if this one dies, it doesn't mean, oh, this one now has only 1 neighbor, so it's going to die too. No, it had 2 neighbors. This one died, but this one was okay because it's at that time interval. Now the next time interval dies. Okay. The next state of the board is determined by applying the above rules simultaneously. Awesome. Okay. Given the current state of the board, update the board to reflect the next state. Note you do not need to return anything. Okay. So we have a board and we want to update this board to the next state. Okay. So what I'm thinking about doing is, obviously we need to update this board itself. But the stipulation about it being like occurring at the same time makes me want to do a new board. Now obviously, just from my feeling is right, I'm adding O of N memory by creating a new board, but I'll show you what I'm thinking. New board is equal to, and this is going to be a 2D array, right? And okay, if not board return. So maybe I can say 0 for I in range here. Okay, and now I want to say rows is equal to board length of board. Okay, columns is equal to length of board indexed at the 0th. Okay, range of rows for, and this actually should just be blank, in range of columns like this. We can make this blank as well. Okay. Alright, so we created this new board. It's a 2D board. Next step that I want to do is I want to just iterate through the board. So for I don't like that I called this rows. Row nums, row length, column length. There we go. Row length, column length. There we go. So for row in board, okay, for column in, no, range, yes, that's what I want. Okay, column length, and now this one needs to be in range of row length, like this. Alright, so this is actually going to be row index, right? But I'm just going to call it row. We know it's an index. Okay, so now I want to check. Let's see, I want to so I have a row and a column. That's going to be like a target, right? Let's just say it's right here. I want to check its neighbors. I want to see how many live neighbors it has. So check how many live neighbors the cell has. Okay. So now that we have our idea of what we want to do, I want to say, okay, neighbors is equal to 0, okay, and now I want to say, okay, what is directions is equal to this right here, and now let's, it's going to be a tuple, and there are going to be, okay, so there's 4 of the cardinal directions, and then there is going to be diagonals as well, which that's like a shifted over, so there's 4 as well, right? So there's 8 in total. So 1, 1, and then 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let's think about what we want. We want up 1, same column, right? So we want the row is going to be up 1, same column, okay? Then we want to the right. Actually, let me just do down. Same column, okay? Then we go left and right, so it's going to be same column and -1, and then this one is going to be +1. Okay, so we have the 4 cardinal directions. Now I want to do the like diagonals. Okay, so what's that going to be? That is going to be, I'm going to say +1, +1. Okay, I'm going to say +1, -1. Okay, 1, -1. Then I want to say -1, +1, and then I want to say -1, -1, kind of like this. Okay, so I have my 8 directions. Okay, so I'm going to say 4 dx dy in directions. If rho plus, I'm going to call this dr dc, okay? Rho dr is within bounds of the array. Okay. Is greater than or equal to 0. Okay. I'll just say it like this. And I'm going to condense it because this is going to be a pretty long one. And rho plus dr is less than length, or column length, row length, and now we don't want it to be equal because that's going to be outside the bounds of the array, and column plus dc is greater than or equal to 0, and column plus dc is less than column length, like this. Okay, so now we're inside the bounds of the arrays, which means I can check, I can say and board indexed at rho plus dr, okay, like this, column plus dc is equal to 1. If this is the case, neighbor plus equals 1. Okay, and now, once I've terminated this, we go and check these rules. So let me take a sip of water and let's read the rules together. Okay. Any cell with fewer than 2 live neighbors dies. Okay. Any cell with 2 or 3 live neighbors lives on to the next. Okay. Any cell with more than 3 dies. Okay. Any cell with exactly 3, any dead cell with exactly 3. Okay. So first one is I'm going to say rule 1, rule 2, rule 3, whoops, rule 4. Okay, so let's do this rule 1. If neighbor is less than 2. New board is new board indexed at row column is equal to 0. Okay? Rule number 2. If 2 or 3 neighbor is equal to 2 or neighbor is equal to 3. If this is the case, new board row column. So I'm noticing this right here, right? So we need to check if it is we need to check if it's a live cell. So this one is a dead cell no matter if it's live or not, right? Because it has 2. If we have 2, it's going to be dead. This one, if it has 2 but it's dead, it doesn't come to life. It only comes to life here. Any cell with more than 3. Okay. So I'm going to say here, if, I'm going to encapsulate, not encapsulate, but like, I'm going to do this, just for clarity. I'm going to say, if board of row column is equal to 1, and one of those conditions are true, then my new board is equal to 1. Okay. This one, a live cell with more than 3. Now notice, more than 3 doesn't conflict with this, and it's going to be dead. So no matter what, it will be dead. So I'm going to say if neighbor is more than 3, new board of row column is equal to 0. Okay. And now this one is going to be I could simply say neighbor is strictly equal to 3, because in this case, no matter if needs to be indented over, no matter if so if it's live or not alive, if it's strictly equal to 3, we're going to put it to live, right? And now I believe what I would be able to do is board is equal to new board. This is the way that I'm thinking about it. Does it make sense? I think so. If it's less than 2, if it's equal to 2, what if it is dead and equal to 2, right? Am I missing that? I believe I am missing that one. Okay, so if board of row column is equal to 0 and neighbor is equal to 2, in this case, new board is equal to new board at row column is equal to 0. And I think I could simplify this a little bit by saying like this and then getting rid of this equals 3, strictly equals 3 because we're doing it there. Okay. So if it's dead and equal to 2, we do this. If it's dead, or if it's alive and equal to 2, if it's alive and equal to 3, if it's dead or alive and strictly equal to 3, and if it is dead or alive and greater than 3. Okay, so I think we covered all of our bases, and then we set it there. Oh, do I want to press this? Okay, let's go. Come on. Did we make a mistake? Oh. Column. Oh. Is it the same one? Okay. Index outside the bounds of the array. Okay, so that's a legitimate error. That is a indication that I don't or that I am not comfortable enough with this for some reason. Okay. Outside the range. Why would that occur? So I did this, and I created this new board. It has length of rows and length of columns, right? Non-inclusive, so it should be a direct mirror of the board. Okay? It should have the same dimensions. I'm doing a new board here, alright? And I'm going through the rows and the columns. Again, non-inclusive of the last index. And I'm taking that row and column of the board and the new board of row and column. And they should be the same size. Okay, so what I want to do is I'm going to come to Gemini and not ask yet, but what was the Python way to check the dimensions of a 2D list? So let's see what it says, and I want to see if I built the matrix correctly. Dot shape isn't a built-in property. Oh, okay, that's what I was looking for, is actually dot shape. Oh, it's NumPy. Okay, no wonder I recalled it in the back of my head. I was like, I think I can do it. Okay, fine. Fine. We'll come here and we'll just do it. We'll do it the boring way. We will do it the boring way. I was hoping to. Anyways, print f like this. What do I want to do? Length of board. Like this. Length of board indexed at 0. Okay. And now we do the exact same thing down below here, but instead of board, we do new board. So new board. Make sure that I spelled it right. Is it like new board? Is it? Yeah, it's the same thing. So okay, let's run this and look at the printed result. Okay. Does it need to be like this? Well, wait, why? What? Okay. Here to there. This one closes it out. This one. Okay. Invalid syntax. Why is this invalid? Okay. Well, this is annoying. I want to know why that didn't work. Print. Whatever. Row length. Print. Column length. Print. Length of board. New board. Print. Length of new board. Indexed at 0. Okay. So now please just show me the dimensions and let me be happy. Okay, great. But okay. 4, 3, 3, 4. Okay. Obviously something is not right. This one should be row. This one should be column, right? Okay. Awesome. So we got it wrong. Okay. Which means we come here. Okay. Okay, whatever. The list of initialization swaps my rows and columns. Yeah. Okay. We fixed this one. We got this one. In place assignment. At the end you wrote here, in Python does not modify the original board. Outside the function, it makes... You must copy the values back to the original board. At the end, you wrote board equals new board. Yes. Python does not modify the original board. Why? It makes the local name board point to a new object. The problem specifically asks you to modify it in place. Okay. Fine. The rule logical. Your rule for rule 2 and 4 overlap might cause issues. Rule to a live cell with 2 or 3 neighbors stays alive. Rule 4 says a dead cell with exactly 3 becomes alive. The logic fix, it's usually cleaner to decide if a cell is 1 or 0 and let it stay otherwise. Okay, let's let's try to fix this one first. Okay, for row in range, row length, for column in range, column length, board at row column is going to be equal to new board at row column, like this, right? But, okay, let me just submit that, see if it worked. But the other thing, okay, so it took it, but we still have a lot of questions. Firstly, I want to know what was wrong with this. What do you mean syntax error? Oh, is it? Hold on. Good. There we go. Because you can't do the formatted print on Python. I didn't realize that I was in Python. Whew, a little bit laggy there. I didn't realize that I was in Python and not Python 3. Okay. That clears up a major, like, what is going on kind of feeling. Okay, cool. Second thing is, I thought that my logic here was correct. I knew that it wasn't clean, but I wanted to make sure I covered all of my things, and I was able, or not things, I should be more specific in my language. I wanted to make sure that I covered all of my cases, right? All of the possible states which it could be in. And I was able to do that. Okay, so now let me see what Gemini is suggesting that I do to make it better. What are some observations that I can make right now, though? So simulation seems to be... I don't want to say simulation, but it literally was just a simulation. Just following rules, essentially. And yeah, the hard, or the difficulty comes from making sure that you index things correctly and that you are able to keep all of the rules straight and that you adhere to all of the different states that it could be. Okay, so, but this was more of a brute force, right? So, what's it saying up here? So if it's equal to 1, yeah, else it's dead, and if it's equal to here, then yeah, okay, that's fine. How to do it cleverly, the interviewer's favorite. Use new board, which takes n by n extra memory. In an interview, the next level question is, can you do it in O of 1 space? That's what I was thinking too. To do this, you use state mapping. Okay, I have never heard of this. That's interesting. That means that we have just learned, or stumbled upon, we haven't learned it yet, but we have stumbled upon a new concept. Awesome. Since the board only contains 0 and 1, you can use either number to represent transitions. So 2 was dead, 0, now alive, 1. 3 means that it was alive and now is dead. Okay, so then after checking, we use the modulo operator with 2 So 2 mod 2 is going to be 0. Which means it was dead. Now it's alive, but then it goes back to dead. Oh, to get the original state. Yeah, that makes sense, because it's, yeah. Okay, so 3, it means was alive, but now it's dead. And if we do 3 mod 2, we get that 1, which means its previous state. Okay, that's clever. You do a second pass to turn all 2s into 1s and all 3s into 0s. Okay, your directions, logic is perfect. Solve the matrix boundary hole in my knowledge. Yeah, woohoo! We were able to be a lot more comfortable with doing these kinds of like where is it? Where did I direction thing, and then checking the bounds and doing that. So yeah, that's good progress, you know. Lapse in references. You're still learning how Python handles memory assignments. So yeah, that's true. This is a common hurdle for people moving from C++ or Java or C. Okay. Okay, so in-place mapping, I'm going to mull it over a little bit, right? Let it think about it a little bit more. Okay. Yeah, I think moving forward, what I'm going to do is I've been working on the number theory, so I'm going to continue to kind of do more on number theory a little bit. But what I'm thinking about doing to move forward with LeetCode and these like coding puzzle questions is I'm going to do one topic, like try to learn one topic at a certain time, and then do the other ones which are more of kind of like the basic problem solving, whatever we called it, right? Like these just problem solving, because these ones seem different than the topics. So right now my topic is number theory, right? But then I'm also doing like simulation. I don't know if that's the correct way to do it, but I don't know. Anyways, or maybe it's just an excuse because I've been doing the number theory. I've been looking at too many primes. So I just wanted a little bit of a break and see about simulation. I mean, these ones seem pretty useful. Like, it seems like these are the type of questions that you'll probably get. So I need to do this a lot more. And these are very much like, that's the other observation that I can make. It's a lot more varied. It's not like one targeted thing. Like, this one is strings. This is a matrix. This is adding binary, right? In characters, that's going to be like a string as well. Adding digits. This one was a 2D matrix. All of these different things are like more, I don't want to use the word random, but they're not focused and targeted, such as like when you go to other LeetCode questions and it's just like, okay, well, do this one very exact thing. So okay, as I mentioned before, this is an exploratory video right here that I'm kind of just trying to figure out, okay, well, what is the simulation topic? How useful is it? How much do we need to do? How do we get better at it? All of these questions I still haven't quite figured out yet, but I am going to be moving in that direction. So if this video is interesting and you want to join me on my journey, subscribe. I would love to have you around and we can go on this journey together. So yeah, my name is Timothy Lee Grant and I'll see you guys in the next video.